So today we're going to work through worksheet number 2. I will do a few of the problems to show you how to set these up, and then we're going to apply Newton's second law of motion, the equation, and solve for these problems. So remember, his second law of motion, the equation is force net equals mass times acceleration. Okay? Now remember, force net, this is when we sum up the forces. And when we sum up the forces, we either sum up the forces horizontally or we sum them vertically. Okay? So you either look at them horizontally or vertically according to what the motion is in the problem. Okay? Another equation we may need later is force gravity equals weight, which equals m times g. And we know that g on Earth equals that negative 9.8 newtons per kilogram. That helps us solve for weight in case we need that. Okay? So this first problem, my picture didn't run off here, but what it is there is a block or a table that has a block on it, okay, or a cart, okay, so let me say this is a cart, okay, and it's pulled horizontally with a force of 3 newtons. We'll say this is a string that's pulling it, so it's going to be my force tension, okay. Now, notice that there is no friction here, so we don't have to worry about friction. So we want to know what is the acceleration of the cart. So we're going to start first with our force diagram, and we are looking at the cart here because we're interested in that. So my force diagram would be this force tension, force normal, and force gravity. Now, of these forces, I need to look at them horizontally and vertically. Vertically, this cart is moving along the table. These two forces are congruent, normal and gravity, so I don't have to deal with those. The force that I'm really looking at here that's causing the acceleration is this force tension, okay? So I could set up my problem and go, hey, force net equals the mass of the cart times the acceleration. And that's what I want to solve for is this. What is the acceleration of the cart? So in the problem, it said that this was pulled with a force of 3 newtons, so that's what this force tension is. So that's what my force net is going to be because that is the only force acting on it, equals mass, and the mass of the cart is 2 kilograms times A. So I need to solve for A. So when I do this, I'm going to divide by 2 over here, and I have to do the same thing here, 2 kilograms. And when I solve this, I would get 1.5 meters per second each second. Okay? So that would be my answer for this. This is what the cart's going to accelerate at. Okay? So that would be my answer. Now, I want to go and look at another problem here with you so that you are familiar with a couple different problems. I have somebody here pushing a cart through the aisle of a store, okay? The mass of the cart and the items are 30 kilograms. The force of friction on the cart is 15. I want to know how hard does the shopper have to push so that that cart will accelerate at 1.5 meters per second each second, okay? So I am looking at, again, the cart. So I'm going to do a force diagram for that cart. So on my cart, I got force gravity and I have force normal. Now, this cart is moving this way. It's accelerating. It's not changing its motion vertically up and down. So these forces are going to be congruent. I know that. So I really don't even have to look at those 2 forces. My other 2 forces on that cart would be this person right here touching it. She's pushing it that way. We call that force applied. And then the other force on it would be the force opposing her, which they told you is the force friction. Now, force applied has to be greater in order to accelerate that cart. And I know force friction is 15 newtons. Now, I like to make force friction negative because it's going against my motion. It's up to you. You could sign it as being positive. You just got to follow through on the problem. So So if I looked at this problem, I know my force net equals the mass times acceleration. Okay? So if I look at this, the mass of the cart is 30 kilograms, and the acceleration of the cart is going to be 1.5 meters per second each second. If I multiply those, I get 45 newtons. That means, this 45 newtons means when I add this force friction and this force applied, they have to equal 45. Because remember, force net, this is the sum of the forces. I have to add up the forces. And the forces I'm going to add are going to be the forces that are horizontal here, because this is where I'm having my motion change, is horizontally, not vertically. So if I rewrote this, if I went force net equals force applied plus force friction. So my force net, I solved that to be this 45. So this is 45 newtons equals my force applied, this is what I'm trying to figure out with, how hard does she have to push the shopping cart, plus a negative 15 newtons, because they told me that the force friction was 15, and I'm going to make it negative since it's going opposite of my motion. So if I have 45 newtons equals force applied, when I add a negative, I really subtract 15 newtons, right? Now, to get rid of this over here, I'm going to add 15. I'm going to have to add 15 here. Wouldn't this be 60 newtons equals force applied? That makes sense. I have to apply 60 newtons in this direction to the left in order to overcome the 15 newtons to the right, and to have a force net, when I add the two together, equal 45. Okay? Now, you could do this problem the other way and make force applied negative. That would still work out and give you the same answer. We will continue with one more problem on the back side of worksheet 2, and then I'm leaving you guys with the rest of the problems to do. I think that's 6 problems, because if I do 3 and there's 9, you should be able to do the rest. And this one's just a little bit different. So I'm looking at number 8 here. I have a skydiver that's falling towards the earth, and they told me the force due to air resistance was 500. What is the acceleration of the skydiver? Well, to start with, we better do a force diagram. So here's my force diagram. So I know this force, air resistance, equals 500 newtons. And then I got force gravity here. Now, I don't know if these are congruent, so I got to figure out, what is the force gravity equal? Isn't that equal to m times g? We've had this before, so we're going to figure out what the weight is. So if I take the 70 kilograms times that negative 9.8 newtons per kilogram, kilograms cancels, I get a negative 686 newtons. That means this force gravity is greater than the force air. Okay, so in other words, this person's going to be accelerating as they're falling down because that force is greater. Okay, but they want to know, what is the acceleration? Okay, so don't I know that the force net equals the mass times the acceleration? Do I know what the net force is? Isn't the net force the sum of the forces? Force net, then I need to add up these two forces. So if I take force gravity plus force air resistance. So it looks like I have a negative 686 plus 500. Looks like I get my force net being negative 186. Okay, now this is my net force, so I can put that up here. I know the mass. Now I can figure out this, what they want me to figure out, the acceleration. So I'm going to go down below here and say force net equals ma. I know this is negative 186 newtons equals the mass of this person, which is 70 kilograms, given in the problem, times a, right here. So it looks like I need to divide by 70, and I need to divide by 70 here. That's going to get rid of it here. When I take 70 into that, I get a negative 2.66 meters per second each second. So they're accelerating going down, and that's what the negative sign means. This just means it's downward. And that makes sense because this force is greater than this force, so they should be moving down. And that's how fast you're accelerating. So I would expect that you should be able to read through the other 6 problems, start with the force diagram, and then you need to realize you're going to use 2 equations. You're either going to use the equation for this weight, where you might have to figure out what the force is, or you're going to use the equation of Newton's second law right here to figure out what is the force net. Okay? So you're going to have to go back and forth, possibly between those 2 equations, and you're going to need to draw your force diagram.